Hello again. So here we go with round two of Volumes of Revolution. I realise I probably skated a bit quickly over the whole mechanics of integration, this inverse operation to differentiation. So why don't we have a bit of a warm-up, see if you can integrate these expressions. Remember, when we integrate, we're doing the opposite of differentiation, so we are increasing the power, dividing by the new power, and then we also need that plus c, just because we don't know if there was a constant which disappeared when we differentiated. So pause the video at this point and have a go. I'll come back and go through them in just a second. Okay, so first one, x squared becomes x cubed over 3. I like to put things in square brackets. I think it's quite important. Haven't integrated, have integrated. 3x squared over 2. Important point, coefficients pass through unchanged. And 2 was 2x, remember, which is the opposite of differentiation. So when you differentiate 2x, you get 2. So there we go. And it's a miracle that I've got 1 minute and 20 seconds into the video and I haven't forgotten a plus c. It will happen at some point. Right, so for this one, before I integrate, I'm going to rewrite it, just like we do when we differentiate things like that. So now I'm going to increase the power by 1 and divide by the new power. Now that doesn't look very satisfactory. Remember, dividing by 3 over 2 is the same as multiplying by 2 over 3. So I'm going to my esteemed and long retired colleague Mrs. Humphrey would always say the 2 pops to the top, so that becomes that. So this one again, I'm going to rewrite it. So we've got to be careful with negatives, haven't we? Increase the power by 1, so that means it becomes divide by the new power. And dividing by -1, same as multiplying by -1, so it's going to be negative. It doesn't really matter where you put the negative, whether you put it down there or up there or out the front. But because the original question was written like this, I'm going to rewrite it as -1 over x. So, I mean, this is correct, but that looks a bit prettier if you ask me. Here, it's important to realise that this is a half times 1 over the square root of x, so when I rewrite it, it's that. And that half is going to pass through unchanged. In fact, sorry, I've forgotten the x. In fact, you often see with integration, people sort of put that half out the front there, just so you know they're not fussed by it. So I'm going to do that. I'm going to put that out the front. I'm not going to forget about it, but I'm going to integrate this and then multiply it by half at the end. So increase the power by 1. Divide by the new power. So that's going to become 2x to the half. And of course, a half times 2 is 1, so we get and you might be thinking, oh, yeah, that all seems a bit too easy. So I tell you what, let's try differentiating. And you know, I'm risking confusing things by flicking between differentiating and integrating, but let's try differentiating this just to check that we do actually get this as our answer. Sorry. So dy by dx is a half x to the minus a half. Yeah, okay, that's all good. That's all good. Okay, so we're warmed up. Where do we go now? Okay, so here's the next sort of level of difficulty. We're asked, what would the volume of this blue area be if it was rotated 360 degrees round the x-axis? So you'd get some sort of donutty shape, wouldn't you? And I guess I'm hoping that you can sort of see how this is done. We need to know this point here. So we don't know what that point is. Sorry, that's supposed to be a question mark. We don't know what that point is, and then we need to work out the area between, the volume that you get when you rotate the red line around the axis between those 2 points, and subtract the volume you get from underneath the black line between those 2 points. So this is a two-step problem. So we've got volume under red line minus the volume under the black line. But of course, before we can do any of that, we need to know this point here. That point is where the 2 lines cross. So we better quickly work out where that point is. So let's ask, where does the square root of x cross 1 over 8x? And you might want to pause the video at this point just to have a little go at that. Okay, I'm going to square both sides. And have I mentioned I hate fractions? Although sometimes they're okay. Perhaps I should have left the 64 where it was. And so, and the other thing is I know it's positive. Actually, when you cube root, there's no positive or negative issues, are there, anyway? So x is a quarter. 4 times 4 times 4 is 64. So yeah, right. Okay, so that's okay. We've worked out that this point is 1/4. So we need to find the volume under the red line. So that is the volume. That's pi y squared between 1/4 and 1, and y squared is going to be just x, isn't it? And the volume under the black line is and in this case y squared will be 1 over 64x squared. We've already met that. Apologise for the seagulls outside, having a lovely time. And of course 1 over 64x squared I'm going to write as 1 over 64 x to the minus 2. And again, it's just like that first one in the little warm-up we did. It's important to remember that it's not 64x to the minus 2, it's 1 over 64 x to the minus 2. Okay, well, I'm tempted to, at this point, say, go on, have a go. Remember the pi, except we can sort of, ignore it altogether, and we could even sort of write it as pi, this, take away this, but yeah, I'm going to stop the video at this point and go away and do this one, and then I'll come back in a minute and we can compare notes. Okay, so it was increase the power divided by the new power. Increase the power divided by the new power, that I rearranged, so that was minus 1 over 64. Bit fiddly, but there we go. I then substitute my values in. It looks a bit of a mess, but yeah, this is this one. So I've got what you get when x is 1, take away what you get when x is a quarter, because we're working between 1 and a quarter. And that gave me that. And then over here, bit more fiddly, lots of negatives here. So you've got minus 1 over 64x when x is 1, and minus 1 over 64x when x is a quarter, and minus is a plus, so that comes out as that, and so that's your final answer. I forget if I showed you this in the last video, but if you're substituting values into something that's a bit fiddly, I mean actually this isn't too bad, but did I show you the arrow X approach? So I want to substitute a quarter into this rather fiddly thing, so I do 1/4 arrow X, and then I can just type in -1/64x, and it works it out for me. And then you can go back and replace a quarter with another value, so if you want to substitute two values in. Okay, and there are lots of questions in the chapter. So it's the last sort of two sections are about volumes made up of more than one volume. So this is one where we were subtracting, but there are also questions where you have to add two volumes together. So for example, page 81 question 2 is a good example of that. Page 81 question 2, where again you work out the coordinates of an intersection, although actually in that question it gives you the coordinates of the intersection, and then you have two volumes to add together. One's underneath a curve and one's underneath a straight line. Okay, so the last thing is problems like this. Can you spot the difference? Well, here we've got a volume that's been rotated around the y-axis. So if I actually sort of try and draw, that's a very bad attempt, isn't it? Sorry. I perhaps should sort of, yeah. So it's going to look something like this, isn't it? So it'll be like a nice open bowl. Again, that's a dreadful attempt. Thank goodness I'm amongst friends, so you know that that's the way I am. But hopefully you can see this time that it's cylinders which are horizontal, and so the height of the cylinder is still the gap, but that's going to be a y value, and the radius of the cylinder this time will be the x value of the function. So I've probably overcomplicated it, because all you need to remember is that when you are rotating around the y-axis, the volume you get is pi x squared with respect to y. So remember, when we were rotating around the x-axis, we had to take the function and square it, so it was pi y squared. So that's what we have been doing, but now we're rotating around the y-axis. So the radius of the little cylinders that we get are x values, so that's that. So there's just a little bit of rearrangement involved here. So my dreadful scribbling, I've covered up the function. So the original function is y equals the square root of x minus 1. So I need to rearrange that so it says x squared equals. So y equals the square root x minus 1, square both sides, add 1 to both sides, and then square both sides. So that's going to be y to the power of 4 plus 2y squared plus 1. If you grid that out, so yeah, so that's so I need to integrate pi times that and it's just the same. I'm going to increase the value by 1, increase the power by 1, divide by the new power. What values are we doing between 1 and 3? So is it worth having another little pause and seeing how you get on with that one? Okay, nearly done. I have integrated, so increase power divided by the new power. 2 passes through unchanged, increase power divided by the new power, 1 becomes y. Y obviously, because we're now differentiating, integrating with respect to y. I've substituted in x, I've substituted in y is 3, although of course on the calculator you have to do it as x. So I'm now going to substitute in y is 1 by just going back up and deleting the 3 and replacing it with the 1, and it redoes it for me, 28/15. Don't forget the pi, so I've got 3, 4, 8/5, take away 28/15, and that's going to be a rather horrible 16/15 pi. Okay, so that's the sort of the other modification really. Rotating around the x-axis, you've got to work out what y squared is. Rotating around the y-axis, you've got to work out what x squared is. And I noticed in the textbook there's a couple of questions where they give you a function defined in terms of x. So, you know, it's rotated around the y-axis, so I need to work out. Well, it's nice and easy in this case because I've already got what x is equal to. I don't have to do the rearranging I had to do. All I've got to do is to square it. So if x is, well, I'm going to write that as y²/2 plus 1, then x squared. I'm just going to have to grid that out. So y²/2 plus 1. y²/2 plus 1, so that's going to give me y to the power of 4/4 plus y²/2 plus another y²/2, which that's 2 half y squares, which is going to give me a y² plus 1. So I am integrating y to the power of 4/4 plus y² plus 1. And this time I'm going between 1 and 4. I keep thinking, has this cropped up before? So with this one, when I integrate, y to the power of 4 becomes y to the power of 5, and then I divide by the new power, which is 5, but I'm already dividing by 4. And just remember, if you divide by 4 and then you divide by 5, that is the same as dividing by 20. Okay, so one final pause. Go and see if you can finish this one off, and we'll come back and compare notes in just a minute. Okay, sorry, was that not long enough pause? Okay, I think that means I've gone a whole video without forgetting a plus C. So there we go. In an exam, you are supposed to only lose 1 mark across the whole paper if you forget. So if you completely forgot plus C's in like 3 questions that involved integration, you are supposed to only lose 1 mark. But anyway, don't forget it, and it's not a problem. So I am straight away going to go to my calculator. Well, no, I'm going to set it out first. So I need to work out what I get when y is 4. I need to work out what I get when y is 1. So here we go. So I'm going to go 4 x. What have I done there? Goodness me. 4 arrow x, and then I'm going to type this in with x instead of y, obviously. So I've got x hat 5/20 plus x at 3/3 plus x. So that gives me 1148/15, and then, I mean, it's obviously fairly, what's going on there? No, hang on, I messed that up. 1 arrow x, is that going to work? Yeah. 83/60. So I've got to do 1148/15 minus 83 over 60, and so that gives me 1503. over 20 pi, and I'm just nervously checking the answer just to check I got that right. Oh, I did. There you go. Wonders will never cease. Right. So the chapter in the book has got lots of practice on that. So the first exercise is what we did in the last video, rotating around the x-axis. Second exercise is what we're just doing there, rotating around the y-axis. Third exercise is what we did at the beginning of the video, the ones where you've got to either add or subtract two different volumes. And then it's got like a modelling section, which is just the same, but instead of it being like sort of random functions, like, you know, like this one, they're in a context. So it's worth having a little look at some of those, but there's no difference there. It's just the same thing. So I hope that's given you enough to sort of get you up to speed on that. And next week in school, we can have a look at anything that you've got stuck on. Although, of course, please feel free to email if you get stuck before then. Okay, see you in a while. Take care.